made it, guys. So, I think I'll be okay not wearing a mask in here, because no one else is in here, but welcome to the John Lukesh lab at Wake Forest. So, I'll give you a quick rundown and talk about it as we go. Okay, so first things first, make sure you have gloves on and goggles when we're in the lab. So follow me. I'll show you the first instrument here on the list. So this instrument right here is a preparatory HPLC, and this is where we get all of our compounds completely cleaned and analytically pure after we do our chemistry. So it's a reverse phase HPLC, so we stick our compounds into the inlet here, and it goes through this column, and then it separates based off of the affinity for the C18 column. And so of course we have our diode array detector, we have our pump, and then we have our fraction collector. So it's completely automated, which is really neat, because at the end of the run all you got to do is come in here, lift this tray up, and then you have all of your HPLC samples ready to go. You just collect them, lyophilize them, and then you should have analytically pure compound in there that's ready for assaying. Alright, we'll make our way to the left here. This is our flammables cabinet. Of course, every good organic synthetic lab has to have a good flammables cabinet. As you can see, we have a lack of shelves right here, so we just gotta put everything down here. So it's better than having it outside in case of a fire. This kind of retains all of that heat on the outside, so it won't get to the flammable organics. So we'll make our way here to the left. So this is kind of our biological benchtop space. And so the reason we call it that is because we don't like to do any kind of chemistry here. And you'll notice here, I didn't clean up anything because I want it to be a raw, exposed John Lukesh lab look. Because on a daily basis, it's not perfectly clean every day. So whoever cleans their lab and whoever shows you a lab that's super clean, they're lying. Because it's not usually the case. But anyway, so this is where we do all of our bio stuff. So anything that we've got to prep in terms of concentration solutions, any kind of well plate assays, we prep them here and then we take them elsewhere, or we let them run here. So we have our biological balances. So of course we like to use these for biological purposes because we keep all of our chemical contaminants out of the way, and so we don't have as many perhaps impurities getting in the way of our results as we would in our bench hoods. So we'll keep making our way down this way. So this is our first bench space that we're going to see in our first Fume Hood is Ritten's. So as you can see, we've got a bunch of glassware hanging on the racks. So we wash our glassware, dry it with acetone, and then hang it on the racks. She's got a lot of bench top space here to do her chemistry, whatever she does here. And behind that is her Fume Hood. So I'll point out whatever all of the points of interest here, and I'll talk about it individually. So first thing I want to talk about is this manifold. This manifold is a we're going to see that in every Fume Hood, and it's just a way to get nitrogen air regulated from the tank into our round bottom flask. We can also have a vacuum line going into a sample, and then running that into the condenser and inside the dewar. So the dewar is typically going to be filled with liquid nitrogen or dry ice, and essentially it's just going to get cold enough to whatever, so that whatever organic solvent in the vapor phase is coming through will just condense here and not go into the pump that's vacuuming it out. So pretty neat instrument too. The vacuum's down here. You can't see it, but it's down there. And then over here, it looks like she's running some kind of column. And what a column is just a it's just a method of separating compounds where the white stuff that you see is a silica gel powder, and it's very polar. So whatever compound you have, if it's polar or non-polar, it's either going to get completely eluted, meaning it's just going to get run down the column if it's non-polar, or it's going to be attracted to the polar silica gel, and it's going to be retained. So that's a good way of separating compounds based on affinity. And then over here, it seems like she's just got a small little dewar So we just put any kind of round bottom flask in there. If we need to keep it cold, we'll either put dry ice or liquid nitrogen and just let it stir there on top of the stir plate. And then, yeah, other than that, it looks like she's just got some other compounds here. And of course, like any chemist, you'll have writing with Sharpie on glass. Of course, you can just wash that off with acetone, but that's a good way to keep record of your actions. All right, so I'll just show you a little bit this way and just more benchtop space on this end. And so we're gonna make our way around this way. So these three things are just, this is just a cabinet for storage. We've got extra hot plates, thermocouplers, lab coats, lab goggles, just good things to have an excess of. And then over here we've got our two refrigerators. Now these are important because in one refrigerator we keep reagents that are stored in our inventory, and in the other we keep our samples that we've made. So we usually store them in 20 milliliter scintillation vials like this. We'll store our final compounds after running them through the HPLC in conical tubes like this, where then we lyophilize them and we're left with this small amount of powder. So this is the analytically pure powder that I was talking about earlier. And then over here, like I said, this is just our reagent refrigerator. So anything that needs to be stored in the refrigerator as a reagent bottle is in there. And we'll make our way down this way. So on the right here, we've got nitrogen tanks. So this is what I was saying earlier, where the nitrogen is regulated through this regulator and then through the manifold. And these are just they're just pure nitrogen. They're good because they keep oxygen out of the reaction flask. If the reaction reacts with oxygen, then it may not work out. So they're good to expel all the oxygen out in our reaction to keep it oxygen free. So we'll make our way this way. And I'll point this instrument out real quick. This is a rotary evaporator. We call it Rotovap for short, but it's a pretty neat instrument because it's got a water bath, it's got a pump, and it's got this condenser. And so what happens is when we put our sample on here, we'll lower the sample into the water bath. So the water bath is probably going to be heated to anywhere from 30 to 37 degrees Celsius, and it heats it up. And as it heats it up, this thing rotates. So those two things in conjunction agitate the sample. And then all at the same time, we've got the vacuum reducing the pressure, and so we've got the sample in the gas form, the gas phase, and then it just condenses on this bullet, which is going to be at -78 when we put dry ice and acetone in there, and that's just going to condense. So at the end of 10 minutes of having your sample on here, we'll have a sample that's filled with some kind of organic solvent. After 10 minutes, all that's going to be evaporated, and we're just going to be left with a dry powder or otherwise just a drier sample. As you can see, more racks for drying glassware. So this right here is our DI water source. So anytime we need water, whether it's in a reaction or in some kind of solution, we're going to get our water from here. We don't ever use water from the tap for any kind of reaction because it's pretty much contaminated with any kind of small particles that might react with our reaction. So it's a good way to get super clean water, and on top of that, it's deionized, so no ions in the water. All right, and so over here we have Chang Lee's Fume Hood, and it's the same setup as Rin's, where you have a hot plate. You have a hot plate. You have a dewar for dry ice, and the condenser, of course. And then up at the top, you'll have a manifold that regulates both the vacuum and nitrogen source. And then, of course, he's got more glassware in there. It seems like he might be running some kind of reaction. And more bench space. And so this thing right here is an oven. So it's not your typical oven that you see it in your kitchen, but rather a just a hot storage for glassware, and it's necessary to put glassware in the oven when you're running reactions that are water sensitive. So we always have to grab these with gloves because it's super hot. And if you notice, it was at 115 degrees Celsius in here. So by then, all the water should have evaporated off. And so this piece of glassware should be completely dry and free of water. So it's important because even if you dry your glassware on the racks, they're not completely dry. And honestly, sometimes some people would argue it's not completely dry in here, but it's the best way to make sure that whatever glassware you're using is as dry as possible if the reaction is water sensitive. And of course, to the left here, we've just got more rotary evaporators. And then right here is one of our UV lamps. So we use these to light up our TLC plates, and our TLC plates are useful to help us keep track of reactions. Alright, so we'll make our way this way, and again, more glassware. And in this corner we've got reagents that we've got on the shelves, and we've got all of these in an inventory, so we're pretty organized here in the cash lab, where anything we want, we'll look for it in the inventory, and then we'll see where it is based off what shelf it's on, and then thereafter it'll be in alphabetical order. And we've got more balances here for measuring out chemicals, and then let's see, we've got just more supplies in those on those shelves. And we'll make our way this way. And this is Chiwei's Fume Hood, and it's set up identical to the other Fume Hoods, where we've got a dewar, manifold, a few stir plates, and then a few columns, a lot of glassware. And this is my benchtop space. So this is shared benchtop space with Chiwei. We've got our notebooks, we've got some more glassware, more solvent supplies. So we're gonna see my Fume Hood next. So this is my Fume Hood. Again, same setup, nothing different about it. It's just a little smaller than the other ones, but that's not a big deal. Fire extinguisher, and of course you've got nitrogen tanks hidden on both ends. And another Fume Hood, and this is an empty Fume Hood. So that's the Lukesh lab. All these other things that you see on the side are just solvents or reagents and supplies that we might need. And then we've got organic and aqueous waste containers there. And let's see, just to recap, we've got 3 rows and a benchtop space, and then we've got our biological benchtop space over here. And now this big window that you see is our study. So we'll make our way in there. We'll take our gloves off and go in there and check it out. Alright, so this is our study space right here. This is, we've got 4 graduate students that have their desks in here. That's Chiwei's, Chang Lee's, we've got my space, and then we've got Rin's space. And so it's kind of neat because we've got plenty of space in here for 4 graduate students, and we also have visibility into the lab. So it's neat because we can see who's in there, and yeah. Well, thank you for coming along and touring the Lukesh lab here at Wake Forest, and I hope you enjoyed it. And let me know if there's anything else that you wanted to see or any other instruments explained, and I'll be happy to explain those for you. Thank you so much.